Well, I have to say, I nearly got there. After doing all the work with the resistors and the termination, I shut everything down, gave it a rest, and started it up again, because I'd been swapping, kind of hot swapping some of the components with the whole RS485 network still on and the Pi still on. So I did wonder if doing it that way, some of the old stale data config, I don't know, was hanging around. So I shut everything down, pulled the power out, started it all back up again, and it was much more reliable. In fact, it ran reliably for maybe half an hour, but then very, very occasional dropouts, and again, missed beats, missed point switches. And although, I mean, that's pretty good, and if when I'm just up here manually running trains around, that's kind of alright, because I'll notice and I'll switch it. But I really want this to end up pretty much automated. I want the layout to drive the trains. That's why I'm getting rid of all the old ones and replacing them with reliable ones with good pickups and responsiveness, because I want to be able to trust all of the components on the layout implicitly, so that the layout itself can drive them and automate them and all that stuff. And once I've got all of the feedback sensors and infrared sensors and block detection sensors installed, then that's where I'm moving to. So I need to carry on down this rabbit hole, I think, and decide what to do next, and investigate if there are any other options that could be, or any other factors that could be causing noise on the data bus. In search of perfection, I did head off down another rabbit hole at this point, and I kind of filmed it, but I'm not going to put it online because it's just more pain. I decided that the only option I had left to make the RS485 data bus perfect, in a sense, was to go down the common ground route, which I've read about and is on that same website that I linked last time, actually. The idea being that all of the RS485 to TTY modules, the little savages here, need to be on the have a common shared ground, so that any interference is, I don't understand electronics to that level, really. So I did it. I had this wire, I had the old 5-volt wire, so I decided what I'd do is I put them all on the same shared 5-volt power supply on the same wire. And so I did that, and unsurprisingly I fried all of the modules again, and nothing worked, and I was back to square one with absolutely no communication. Now, I think the error I made in doing that is that although I gave all of these TTY modules, so each of the 3 modules that are on the 3 different nodes shared a power supply, and everything else, the Arduinos and the PWM boards and everything else, were still on their own individual local power supplies. I think the mistake I made with doing that is, although the documentation for or certainly anecdotal documentation for these things says that it's recommended that all of these modules be on the same common ground, it's also recommended that, I think possibly mandatory, that any module that's attached to the Arduino needs to be on a common ground with the Arduino, which just started getting, so I was going to go down that route, but that's just getting way beyond my electrical understanding. So I basically need this common ground on a 5-volt supply plugged into all of these TTL modules, plus I would need that ground supply to also be connected to each of the Arduinos, even though they each had their own power supply. Because I don't understand electronics enough, to me that sounds like a big risk of setting my house on fire. So I've stepped back for that. It just doesn't seem worth it for where I am. So I've decided I'm just going to accept, at the moment, unless I have some massive brainwave, I'm just going to accept that RS485 is going to have errors sometimes, and I'm going to need to mitigate the risk of those errors having an effect on the layout. On saying that, one useful bit of documentation I did stumble upon Sometimes you read things and people tell you to do things and you don't quite understand why, and you do it. And one of those was this twisted pair thing. I thought, well, it can't do any harm. So when I pulled this cable, I did my best to twist it around. And it was sort of the documentation of the places that said you should do it said it reduces the risk of interference getting into the data. And I now understand it doesn't actually do that at all. But what it does is if there is going to be interference get into your data, these two wires effectively carry some kind of differential, kind of say the pink one's the negative and the purple one's the positive. They carry a differential, and then somehow, again, this is way beyond my understanding, when the data gets to the point it needs to get at, there's some kind of differential done between the two bits of wire, and it's a kind of redundancy. So effectively you kind of have the same data travelling down two wires. There's then a redundancy check done when it gets to the end point, and sort of the difference between the two becomes the data, something like that. But the important thing, the thing I understand now, and the reason why these twisted pairs are important, is it doesn't reduce the risk of interference getting into the data, but what it does do is if interference is going to drift in somewhere, there's a likelihood that the same interference will affect both wires, and therefore the differential when it gets to the end will still be the same. So yeah, it doesn't reduce it, it just increases the chance that it will affect both wires the same way. My plan now for mitigation of failed commands is feedback sensors. Now, it's not going to be perfect, and I'll come to that in a minute, but with every one of these mounts and most I've built, I have put a micro switch on it, and I've kind of dangled a couple of wires from it so I don't have to solder under the baseboard. So it is kind of all set up for feedback sensors for points. So I decided to wire a couple in. So if I just come out here amongst this beautifully organised spaghetti junction, this one is now connected to a chalk block there, and is wired. The wire comes down there, and that I'm starting to plug them into this sensor shield on the Arduino. I've modified the sketch that I'm using. I might go into it in another video. I won't do it now how I've done it, but what it does is I can effectively, just for ease of use, I can plug the micro switches into any port on here. It doesn't really matter what number it is, and then with a tiny little bit of configuration in the script on the turnout, the sketch will translate that pin into the matching input address of the output address of the associated turnout. So basically what that means is this motor here, this set of points has a CMRI address of 2001, and the sketch will therefore make sure that the micro switch attached to it also has a CMRI address of 2001, which just makes matching them up as feedback sensors much easier in CMRI, JMRI. And here in JMRI, that's made the feedback sensors for the turnouts relatively straightforward to set up. In Panel Pro, Tools, Tables, Sensors first, and I've set up two sensors called the micro sensor incline bottom 2, micro sensor incline bottom 1, just so they match to the incline bottom 2, incline bottom 1 of the point motors that they're feeding back on. Exactly the same ID, 2001, 2002, as their respective turnouts. And like I said before, the script, the sketch on the Arduino handles the matching of addresses, and the way it does that is in that I've added a property to each turnout class called, well, two properties in fact. First one is feedback sensor input pin. Second one is uses feedback, a boolean that says uses feedback. Then the idea being is when it processes, obviously the main part of that sketch is to process turnouts and to get feedback, so it goes through each board and each turnout one by one. Now as it goes through the turnouts, it checks to see if that turnout uses feedback sensors. If it does, it gets the value because it knows the pin, so it's set up with pin 10, whatever it is, goes and gets the values from of pin 10, and at that point, when it knows what the address of the turnout is, because it's just read it, it can then send back to CMRI, JMRI, the feedback sensor value, and send it on the same ID. So what that means for me is I'm planning to end up creating feedback sensors for all of these sets of points, and each one I don't need to worry about addresses. I just know when I create the corresponding feedback sensor, I just create it with the same ID and the same name as or almost the same name as the turnout, and the sketch and CMRI and JMRI will look after the rest. These are on-off switches, so there should be no debounce. They just turn on, they turn off when they get switched. And then into the turnouts, it was a case of, for the ones that actually use them, let's go and look at this one. Feedback, one sensor, select the sensor. This is incline bottom 1, so select the sensor micro switch, incline bottom 1. Now I had to set a larger interval. I was getting some strange behaviour at this point on when I set it up with the default values. It seemed to be overcompensating, let's say. So my understanding, once you've got a sensor, a feedback sensor set up, the process is in JMRI, I click the button because I want to change a set of points. Message goes down the RS485 bus through the Arduino. The Arduino changes a set of points, but at the same time the Arduino is multiple times per second sending feedback back to JMRI saying this is the status of the switch. But of course it takes 300 microseconds, however long it takes, some time for the motor to move the arm and move the set of points from one position to the other position. And it's only when it's fully moved to the new position that the button on the micro switch gets pressed and the feedback to CMRI and JMRI that this point has now moved, you were successful. And I think there's a period of time in between where it's not getting the message back that the set of points has moved, so therefore it's taking remedial action rather than waiting a little bit longer to see if it moved. My understanding of, again, JMRI and CMRI also is that if it sends an instruction to move a set of points, say from closed to open, it sends so that bit used to be a 0 and now it's a 1. So it sends that change from 0 to 1, goes through CMRI, and it goes off through RS485. That instruction is received and acted upon, or not received and not acted upon. If it then gets feedback that instruction wasn't acted upon, or it comes to the conclusion that it didn't work, it can't just send that one again, because CMRI and maybe other elements of JMRI will just detect that there was no change because that bit was 1 anyway. So it can't just change a 1 to a 1 and expect something to happen. So what it has to do effectively, if it thinks that it sent an instruction to a set of points to go to thrown and that set of points didn't go to thrown, it has to change it back to closed in order to change it to thrown again. And that's what creates the flapping around. So I've had a lot of experience, and I'll try and insert some of it over here. A lot of experience of sending the instruction to move from close to thrown, throws to clone, and instead of it just happening, everything flaps around for a while. It goes closed open and messes about, and then eventually settles on where it should be, which is annoying and far from perfect. Obviously, no debounce delays on the sensors, but the one thing I've found that does seem to have a positive effect on it and reduce it happening, I haven't stopped it happening, but reduce it happening, is to change this interval value to a low value. Now, that doesn't make sense to me. Initially, which is why I've called this new automation setting larger interval, because I would think it needs to wait longer, not a shorter amount of time. If it's throwing the point, getting the feedback too quickly that it hasn't thrown because the motor hasn't moved yet, and then it's acted upon it to do it again, that explains it to me. So I would increase this value, say, well, actually wait half a second, 3/4 of a second, maybe even a second to get the feedback, because it's not going to come instantly, and then maybe act on it if after a second the thing hasn't moved. But I tried increasing that value, and that just made it worse. It just went bonkers and bonkers and bonkers. I think the default's 300. So in the end, I brought it down to 100. It won't let me go below that, but it's certainly much more settled, and the flapping around happens a lot less often at 100. Another lesson I learned here, actually, which is worth mentioning, is these boxes are lovely and editable, and you can change these values. Let's change that to 800 and click apply, and that's happy, and click OK, and then come back in and it's 100 again. And for quite a while I thought this changing this value had absolutely no effect whatsoever, because I didn't realise it wasn't actually changing this number. I was clicking apply, clicking OK, and then going off and testing it. Nothing happened, and just thinking, okay, well, that doesn't affect it. This is a bit of a user interface error on GMRI's part, in that these should not be editable, because they're not editable. You can't change these values here. You have to change it. These are inheriting these values from the setting for this larger interval, and you have to change it for this setting, not here, because it will always inherit from there, and any changes you make here just get discarded. And the way to actually change this is to go into the automation menu when you've got turnout selected, edit, larger interval, which one I created, and change it here. And changes you make here will affect all of the sets of points that use that larger interval. Because I called it larger interval because I thought it needed a larger interval. It's ended up being a smaller interval, which is very counterintuitive, but I'll change it at some point. But what that ultimately means is now I have this turnout acting on sensors, and let's see if it does this sensibly or if it goes crazy. That was a good one. So you can sort of see the difference in the delay that this goes red. If I go and change a double set of points that doesn't have a sensor on it, doesn't have any sensors on it, this goes red straight away, because this is a JMRI decision now. JMRI says, well, I've sent the message, I've got no feedback on it, so as far as I'm concerned, sending the message to change the points was successful, so I'm going red. Whereas here, it is waiting. If I go and get my sensors back over here, see if I can get both on the screen at the same time. So this incline bottom 1 and incline bottom 2, these two in the middle, it's waiting for a response from these before it says, yeah, that was successful. So click on here again, they change, and then it goes black. So it's not assuming that just because it sent the instruction to change it was successful. It is waiting for that feedback to tell it that it was successful. Up until recently, although I've fitted one of these micro switches to every single mount that I've put under the baseboard and soldered these cables coming out of them as well, I didn't actually know whether I was going to really connect them all up to the Arduinos and have them as feedback sensors. But my experience with RX485 up to this point has led me to the conclusion that I am going to do it, because there will be times, it seems, when an instruction is sent for a set of points to change and that set of points won't change. And if the layout is automated, if the layout itself is driving trains, then that could lead to collisions and derailments and short circuits and issues. Having these feedback sensors will reduce the risk of that, because the layout will in theory know that a set of points that it tried to change didn't change, and it will have more accurate information on the current status of each set of points. Of course, I have the risk of double negatives in that these switches feed back on the same RS485 bus that I'm having problems with. However, I would rather have, so the issue there, of course, is that JMRI gets a message back that a set of points didn't throw and is in an unsafe position, where actually it did throw and it's in a safe position. However, I'd rather have that, because that will still, the choice is to either not have errors reported and have the layout carry on as normal and possibly end in collisions because it will put two trains together, or have false errors reported and have the layout stop when it didn't need to. And I'd rather have the latter. So I'm going to set about getting all of these motors and mounts wired up and into the Arduinos as feedback sensors. And since I'm on the subject of sensors, I've been thinking for a while about how this yard will work if I am going to have automation and have warrants and dispatches and all these clever things, and have effectively a computer controlling trains and sending them around the layout. I'm obviously working towards block detection, so say with this layout, forgetting that there might end up being an upper layer and will end up being an upper layer, with the layout as it currently is, the idea would be to have the computer, the JMRI software say, right, I'm going to take that the rightmost one, the blue-grey intercity, and I'm going to bring it out of its siding. I'm going to send it on a few laps of the layout, and then I'm going to bring it back into its siding and park it again, and then I'm going to do that with other trains as well. What I need for that is block detection to start with, so that the layout knows that the route it wants to take the train on is clear, and also some kind of block detection in these sidings as well, so that it knows the siding's free to park it. And I could put current detection on each of the lines, but the issue in my head with that is that I've started double parking, because I've got long trains like the Intercity and the APT and whatever, but I've got short trains like the DMUs, like the Class 101 that's at the front there, and a couple that are down here as well. And if I just have one current detector on that entire rightmost line, or whichever one, it will report that there's a train in there, but it won't report how long that train is and whether there's space for another train to park on the end of it. And I need that because I have no sidings dedicated to DMUs. There's nowhere really convenient to put any, so I need the two to work together. So I need to look into a system that can report not necessarily whether there's something on each of these siding lines, but that there is something on the siding lines, where it is, and whether there's space for something else. And the idea I'm currently processing in my head is to have infrared sensors at various points down the siding lines. The idea would be the first infrared sensor, and I've got a trial one here, would be close to the front of the line. So these are the anti-clockwise lines, these four here, the anti-clockwise sidings, these four. So have a sensor right at the front of these lines, and that sensor, with the block it was sat in, would tell JMRI there is something at the front of this siding. Then have another, and I'm going to have to walk with this one, have another infrared sensor. If I move, this is my longest, I class this as a DMU I suppose because it's relatively short, and I've just decoupled it, but this is effectively this is the longest DMU, the 3-car class 159, is it, Trans-Pennine Express. So say this is sat right at the front of this, and there's a sensor somewhere around there that says this is occupied. There's then another infrared sensor, the length of my longest DMU, although I might have to start assigning specific trains to specific sidings for this to work really well, which I'm prepared to do. But say there's another sensor then here, and this is in its own block as well. So this where this DMU is, that would be a block, and then that would be governed by the infrared sensor that would be right underneath the front, and that would say there's something. That sensor over there would say there's something on this line at the front. But there's then another sensor here, so which is the length of the longest DMU away, or maybe something more specific if I assign specific trains to specific yard lines, sidings. So there's another IR sensor here, and this is its own block. And if this is free, that means there's a short train at the front of it. But if it's occupied, that means there's a long train at the front of it, because all the long trains are longer than this point. Then there's another, say if we take this line with the blue-grey intercity on it, there's another sensor, the length of the longest long train over there, so just after the end of the intercity. And that's in its own block as well. And that would therefore say there's a long train parked at the front of this track. And if that was free, that would mean a short train could park on the end. But if it was occupied, that would mean a short train is parked on the end and this line is entirely unavailable. That will, of course, be incredibly useful as well for these lines that I won't be able to see once there's walls and stuff here, because it would be handy. These are the 3 longest lines, actually, the ones that are covered up. So it would be handy to be able to double park along there as well. But I wouldn't be able to see it, so I would be entirely reliant on sensors being occupied to know where to stop the long trains and where to stop the, if I'm driving the layout, where to stop the short trains in order either not to collide but also leave enough space for something to park up behind. And then if I'm getting to full kind of automation time, have trains that say the long intercity gets pulled out and drive, or say the Transpennine Express gets taken out, have the APT, whatever's driving the APT, to regularly check to see if the sensor in front of it has become free, and if it has, just shunt itself up to occupy that sensor in order to free the space at the back of this line for the Transpennine Express, which is currently doing a few laps, to just pull onto the end. So I think with 3 infrared sensors per siding, there's a good chance I can achieve that. There are doubts in my mind. I would need to have some kind of each, I think they call them warrant, the kind of the thing that represents the train itself, would need a way of storing information, because none of these trains, when I start the layout up, none of these trains have any way of knowing whether they're at the front of a siding or at the back. So what I would need is some kind of setting, say when this, or some kind of storage table, or I'm sure it must have it, when this Transpennine Express sets off along from the front and goes off on its journey, it sets a setting on JMRI to say this train with this ID is now at the back, because it's going to pull onto the back and it's probably going to pull onto behind something. So it'll go off and it will have a setting that says I am at the back, and then this intercity will shunt itself forward and it will set its setting to say I am at the front, and that needs to be stored in JMRI, and it needs to be checkable and retrievable, so that when the layout starts up and nothing knows where it is, and a timer or a trigger, whatever it is, tells this Transpennine Express to go and do a few laps, it needs to be able to check and say, am I at the front of my siding? Because it can only be allowed to tootle off if it is at the front, because if it's at the back, it's just going to drive into the back of the APT, and I don't want to be sending it back off to Hornby again. So I have a lot of doubts, but I'm just going to keep going, kind of do a little proof of concepts and see how far I get with it. So in the spirit of prototyping, I decided to set up an infrared sensor and see if I could get one under the layout in a position where it would reliably report if anything is basically parked on top of its head. Before I get to the success or otherwise of that, I'm going to highlight another beginner error that I managed to make and cost me a day of troubleshooting when it was something actually really simple. So this IR sensor is connected to this Arduino, and I put a little thought into which pin I would connect it to, purely because there are going to be 2 types of sensor attached to this Arduino. The first lot are going to be the micro switches, the ones I just mentioned, the feedback sensors for each of these sets of points, and there's a couple back there as well. So they're all going to have feedback sensors, and they're all going to be plugged into here. There's a chance that this Arduino will have 3 PWM boards. Each PWM board has 8 turnouts driven by it, because of the way I use the relays for electrofrog polarity switching. So there's a chance of needing 24 inputs on this board purely for micro switches. And if I'm going 3 sensors per line on the storage lines on the sidings, then, and there are 9 sidings, then 9 times 3 is 18, but they're going to be split because the anti-clockwise ones are at this end, so they'll all go into this Arduino, and then there is another Arduino under that far corner, so the ones over there would be split. So they'd probably roughly be half and half, so 26, 13, so maybe another 13 coming into here, inputs for IR sensors. So I thought, well, I'll split them up, so I'll leave 24 inputs for the micro switches, and I'll start, I think I ended up thinking, right, I'll start at number 34. Pin number 34 can be the start of the IR sensors, and that leaves plenty of capacity for both. So having done that, I thought, well, in this, again, in the script, I really want the ID in JMRI to represent the pin number for these, although I'm doing it differently for the turnout feedback motors I explained earlier. In the case of these IR switches, really I want the ID in JMRI to match the pin number that it's connected to on this board as closely as possible, just so that it with all the other things I get wrong and get mixed up, at least it reduces the chance of me mixing that up. So I thought, so I started at 34 here, and I created the way the sketch works. Effectively, it should be 34, ID number 34 on JMRI. So I created, this is node 1, so I created a sensor with ID 1034 and nothing in JMRI. And I went through everything. I went through the script, I went through every setting in the sketch. I put so much debugging into the sketch to make sure that it was detecting a change and that it was sending that change to JMRI, but nothing in JMRI. All I got for that sensor was unknown, and no matter what I did, I changed all the cables. I thought what I couldn't understand was, in my mind, this Arduino was receiving instructions fine, but it just wasn't sending any, because I couldn't find any evidence in CMRI monitor or JMRI itself that it was receiving any data relating to pin 34 here and input ID 1034 through the node, the CMRI node, and into CMRI. And I was right. It wasn't, but it was for a very simple, basic reason, and it took me a long time to find it. And back here at JMRI, that very simple reason being, in Panel Pro, if I go to Preferences and Configure Nodes, now I had all 3 of these set up as S-Mini type, not the SUSIC, whatever that one's called. And the pure reason why I'd done that, if I go and pretend to add a node 4 here, was if I set up an S-Mini, all I have to do is click add node and it works. Whereas if I set up a SUSIC and I try and add a node, it'll give me errors. It say I have to select card types and that kind of thing. So me being me, just thought, okay, well, I'll go back to S-Mini and I'll click add node. And it works. There's node 4 added. But these S-Minis, they have some statistics here. The key one being in bits 24. So what I've learned is that means it listens for this node, which would be node 4. CMRI will listen for input, for sensor input from IDs 4001 to 4024, and it won't listen to anything for anything in excess of that. So for node 1, which is where the sensor was, I had 24 in bits, and I was sending the status of that infrared sensor in on bit 1034, but it was only listening from 1001 to 1024, so it just wasn't even entertaining the fact that I might send something on a higher value. So the resolution was to swap from S-Minis to these SUSIC things, which have, with a bit of configuration, have 64 in bits and 32 out bits, which now means it's listening from 1001 to 1064 and instantly started picking up the status of that sensor. So the first issue I felt like I had to overcome if I was going to successfully use infrared sensors on this yard was getting them mounted in a way that they could effectively be used. I've seen examples of them sitting kind of alongside a track, but I really didn't want that. Although a lot of this is going to be covered up, that's too bulky. If I'm going to have these, they've got to be underneath the layout. They've got to be hidden away. So I tried this one first because it's got that little raised square on it. I thought if I can drill a 1 centimetre circle in the baseboard and kind of mount that so that the square thing's going through into the circle, then this edge bit of the sensor here will be flush to the bottom of the baseboard. I can screw it in there and wires will still connect nicely there and go off to the Arduino. The mounting worked fine, the sensor didn't. These are tiny little LEDs, bulbs, whatever they are, and it wasn't even anywhere near the top of the hole, and it just didn't sense anything over the top of it. If I stuck my finger in the hole, it sensed that, but nothing parked over it. So I tried a few times and quickly decided that it wasn't going to work and almost gave up. I also had these IR sensors as well, and I hadn't even considered them because they seem impossible to mount, because that's obviously, you know, the direction the sensors want to go in. It's an awkward size. I think it does have a screw hole in it, but there's nothing obvious near where it would mount that I could screw it to. So I'd almost discounted it before I even gave it a go. But once this one hadn't worked, I thought, well, I'm nearly there. I've got the cable in there. I'll give it a go. So the hole I'd already drilled, I tried to stick one of these vertical sensors through it, and quite miraculously it went in quite well. If I come down underneath the baseboard, it simply shoved, and the light's maybe a bit bright for you to be able to be able to demonstrate it, and that certainly doesn't help. But it's effectively shoved through the hole. No too much under here really, but there's absolutely nothing holding it in. But because it's about the same width as the diameter of the screw hole, it actually wedges in and sits there really quite comfortably. And what surprised me even more, if I just come back a bit and try and get both sides, is it actually works perfectly. If I just roll this, try and get both, try to derail it, there we go. As soon as this little wagon rolls over the hole that the sensor is shoved into, it senses that it's covered, and it does it absolutely reliably. Okay, it flashes a bit at first, but that's just debounce, you can sort that out. But once something is parked over the top of it, it absolutely categorically recognises that its view is blocked, and it does exactly what it needs to do. It changes its state. So I wired it up and I sent it into JMRI, set up a sensor in JMRI, and it's really quite straightforward. I then created a block and assigned this sensor's output to that block, and I'll hopefully record the desktop of this happening and now add it on. But the same thing, if I switch it to unoccupied and occupied, that block now, although it's a little bit ugly, obviously I can't see it, but I'm imagining it because I remember how ugly it looked when I set it up. I might need to create something that's a bit smarter, but it does reflect that this first segment of track on this siding, this initial block, the front block, is occupied. I haven't given much thought yet to block detection, but the conclusion I've come to is there can be different types of block detection that are relevant to different requirements around your layout. Like here, for example, as I went through before, I need to know not just that a siding is occupied, but how it's occupied and where it's occupied. And maybe block detection could do that to an extent if I had resistor wheel sets on all my coaches and that kind of thing. Maybe splitting each of these lines into 3 sections and having current detectors underneath them would still work, but it would be a lot more expensive and I'd have to do the whole resistor wheel set thing. Whereas this is a much more simpler and uglier solution, because I've got these big holes with bulbs coming through them. But it suits my requirements more in that I want to know not just that a siding is occupied, but where it's occupied, where there is a potential for shunting to create space at the back end of it, where there is space at the back end of it for something to park up and shunt up behind something else, and when it's fully occupied. And positional sensors like these ones help a lot with that. And in addition, actually, I think, ugly as they are, they're almost going to be invisible for a couple of reasons. First of all, there's going to be a cover coming over here and then going off down to the end there, so all this will be covered up. Another idea I had, because they're going to be covered up with boards like that, I'm going to stick tin foil underneath the base boards, just to help with the reflectiveness and the effectiveness of these sensors. There will have to be some sensors down the middle, say down around there, but that's kind of okay, because these lines are so close together, you really have to get up to a high up angle to see it, and frankly I don't care. The usefulness of them outweighs the ugliness of them, and of course they're going to be, this is already full. I'm not going to have empty lines here. This middle line will always be empty because it's a through line, but that's not going to have any sensors on it, or if it does, they're going to be current detectors, because it's a different kind of occupation that I care about with those lines. The ones under there are covered already, of course, so they're not going to be seen, and this yard is already occupied, so the majority of the time there is going to be something parked over most of the sensors, so they're hardly going to be visible, and I'm certainly not concerned about the ones that will be.